how's the audio? Is it too loud? Is it too loud? For the like music? It's fine. Okay, cool. So we got, let's see, we got Kaiser, is Felix, we got my Procast, Kenny, we got Randy Y, or Randy Garcia, Clips, and then we got Manny Gray Eden, and who else we got? I'm trying to like put together the pieces. I know there's some other people watching. If you're not in the class, just say hi too. All right, so let's, okay. Randy Rodriguez, Legendary Rain, Randy, I'm putting it in my notes, Legendary, so I can get you, so I can know who you are. Okay, so we're gonna go ahead and begin. So for those of you that are in the class, when we were on Blackboard, we were talking about, I gave you a little preview of what we're gonna do today. So we're gonna continue working with what we've done already. So we're working with our board. So I'm gonna go ahead and switch to my display here. So we have, this is our script from last time. So I added some stuff that we did together in the class on Blackboard Collaborate Ultra if you were there earlier. I commented out though, so those were just examples, so you don't have to worry about them if you're looking at it later. We talked about several things we're going to do. We're going to talk about custom functions. So how many of you have used custom functions before? Let me know in the chat if you've used custom functions in either GD205 or another class. Does anyone know what a custom function is? You have. Awesome. Excellent, excellent, excellent. So why would we use custom functions? Anyone have any ideas for why? Or like even what it is? Of course, this is the thing where like I ask questions and like it's a pain in the ass to type out like an entire answer. So maybe I'll try to keep the questions simple or like shorter answers. Like just throw a color in the chat. So short and large command. So yeah, so you can like basically like organize your code in a way that like, thank you. So also to make it cleaner. So those are definitely very good reasons to use custom functions. So like if we go here, we have like a whole mess of code, right? It's all kinds of stuff here. So like if we're trying to think about like, we can think about like, what are we gonna use to organize this? So we have something like where we are, and I'm actually, to make this, because of scope, I'm gonna actually declare this new position up here at the top. So I'm gonna do a new vector3 called new position, and then instead of declaring it here, I'm making this vector3 a global vector3 so that I can reference it in these functions without having to do anything fancy. So what I can do is if I want to create a function, so like we have two built-in functions already, right? So we have start and then we have update. And so if we go down to the bottom, like what would be a good way to, let's say that we're going to move all this stuff into a custom function. So like what might be a good way, I could also, getting rid of that declaration because we already declared it at the top. So how would we describe this stuff? What might be a good name for a function for this stuff? So movement, so we could think about it as like maybe movement input, because we're like registering each key. And so what I'm going to do down here is I'm going to go outside of update, and I'm going to create, let's say I make a new void function. I could also make it public, or we could call it controls. So we could call, so the void controls, and I could also make this, so we can now refer to this inside of here. So what I can do is I can go back and I can move all this stuff. So I can control X or command X, so that will cut it, and then I can paste it into here. And the reason why I cut it is because when you cut it, it actually takes everything away and stores it in the clipboard so you can move it. Because I know a lot of people, when they work with the clipboard, they copy it, delete it, and then paste it. But it's actually an extra step you don't have to do. So if you're trying to like move something, a cut is a lot more efficient. So this way it's all organized here. So like, what do we have to do to make sure that this runs? Because right now, if I run this code that's inside of here will not execute. So what do I have to do to make sure that this runs? And it's okay if you don't know. You could just say, I don't know. There's no shame in not knowing. In fact, it's good to not know because then we can address it. Cool. So when we create this function, it doesn't run automatically, right? So like, we know that update and start run automatically because they're like built-in things that already have their own rules. But when we create our own function, we actually have to do what's called calling it. So does calling it sound familiar? Calling a function? So that means that we have to actually go back to wherever we would want this code to execute. So we would want it to execute right here, right? So this is where we were before. And so we have to actually call that function. So we use the name of the function, which is controls. So if I save this, and I'll go check it in a minute, it's gonna go through and it's gonna execute this first line of code. So this is storing the current position, and then it'll run controls. So it'll look for the custom function called controls, and it'll find it down here, and then it will execute all this code. So it helps us to organize everything by like a certain type of thing. So I'm just gonna save this, and I'm gonna go back into here. And thank God, no errors. I'm gonna run it. And there's literally nothing different about what we've done. It's doing the same thing. So no problems. And so if we, but it does help us to organize and does help us to read it easier. So we could also think about like, maybe I wanted to make a custom function for like updating the position. So I could cut this as well. So that's Control X on the keyboard. And I can make a new custom function here. So public void. Void is a type of function. So I could call this update position. And then I paste that content. And then don't forget, we have this here, but it's not going to run automatically. So we have to go back. And then I need to put it here. So I called it update position. And don't forget, when you see the parentheses, you know that it's referring to a function or a method. And so you know that it's referring to something else outside of it, either in this script or somewhere else if it's referring to something else. So like for instance, you have like play one shot is a method. So it's just a function somewhere else in another script somewhere. So we're just doing this for our local stuff. Actually, the music is like too loud on my speakers. Let me turn it down. I'm gonna like, I feel like I have to like talk over it even though it's not bothering you all. Okay. Can you all still hear it okay? I feel like the music is an essential part of this class. Because I don't know. I feel like it relaxes you. I don't know if that's true. Do you feel relaxed when you hear the music? And is the level good? Okay, cool. Okay, so when we go back and look at this, so now we can think about, here we checked for the hazards, right? So I can make another custom function. So I'm gonna take this stuff, I'm gonna cut it as well. and I'm gonna make another one. I'll call this one public void check hazards, right? And sorry, there's a typo there. Check hazards, and then open and close curly brackets, paste it in. So all I'm doing is basically reorganizing this code, and I have to make sure to call it. So check hazards. And if I wanted to, I could also move this into the controls. And so now what we have is that when we look at our update, we can actually just read it off and we can understand the processes that are happening here. So I know that the controls are happening first, and then I know that it's updating the position, and then I know that it's checking hazards. So it helps us to abstract it. And then also, like, if we wanted something to happen multiple times in one update loop, we could do that. We could just call the function again if we wanted to. So does that make sense? Like why we might use it and how we might use it to organize the code, or to like do something like another time, for instance. Cool. Any questions? People good with that stuff? Okay. So the next thing that I mentioned that we were going to cover was that we're going to create like a path. So like right now, when we play this, like we actually don't know where the player has been. So Randy Rodriguez, or Legendary Rain, as I should say, I just asked what the public is for. So like public makes it accessible. So like I could actually just call this, I actually don't need the public here. But what it does, it makes it like if you make this function public, it means that I can, in another script, I can actually call this function. So I can reference it. So remember how when we make the variables or like these objects, when we make them public, it allows them to be, we can modify them in the inspector. So it's like a world outside of this script can access it. And so that's basically what it is. So it just makes it accessible outside of the script. But yeah, it's technically not required here. Okay. Do people know about other types of functions besides void? Does anyone know why it's called a void function? Because that's the type of function. And if you don't, that's good. Tell me, because we can talk about it. Other people? Okay, awesome. So this is a good opportunity. So let's say that we wanted to create a dice rolling machine. Not a dice rolling machine. Let's just say we wanted to do a die roll. And so Randy said it's void because you're asking the computer to do it without question. Not quite. So it's void actually because it does something, but it doesn't return a value. So like what this does is when we call it, it just executes all the code in there. There's like another thing that we can make functions do that like, so have we mentioned debug.log in this class? Debug.log. Have we talked about this? And sorry for all the typos. So if I save this is basically like a print line. So this is a debug command. We could also use print line or print. So like if I run this, I'm gonna see in the console all of these console messages. So I can see that it's giving me a console message and it's telling me in the number here how many times that message has been sent, which if you can see that number, it's very high because it's giving that message every single frame. So it's like 60 times per second. So now it's like it's over 3,000 at this point. So that makes sense? It's just basically like print line. It's a debug command for the console. Make sense? Maybe I should make another. Actually, I'm gonna make another script to talk about other function types so it's clearer. So like if you want to look at one example, you'll be able to see one. So I'm going to go ahead and go back to my project view here. I'm going to create a new C# script, and I'll call this one dice roll. And I'm going to open it up. And so we have, you know, just our basic script here. And I'm going to create an int function. So you can create a function that's not a void, that's like an int. So I could also create a float function. So when you create a function, so like let's say die roll. So we have die roll is going to like roll a die at some point. It's not there yet. So let's say that we have in our start function, we want to send a debug.log command. You rolled a, so this is like the text that it'll show. And then I could give it a value, like I could say like 12 or something. But instead of that, I want to use die roll. And so what this will do is it will, when it gives this console line, it'll say you rolled a, and then this function is called. So it's going to look for the function called die roll, and then it's going to run it. And since it's a float type, what it expects is it expects it to return a float. So like what that means is that a value will be passed back to where you called it. So this die roll will be replaced by a float value. So like let's say that let's say that this game is rigged, and like I wanted to like return a value of 1, and I'm gonna say F since it's a float. So I'm gonna try running this. So like if it works correctly, what's gonna happen is when I first run my game, in the very first frame, it's going to run this debug.log. It's gonna say you rolled a, and then it's gonna call this function die roll. It's gonna run this. Any code that is gonna happen is gonna happen inside of here, and then it's gonna return a value of 1. So then it basically like teleports back and converts this into a value of 1. So I'm gonna save this. I'm gonna cross my fingers that I didn't fuck up. Looks okay so far. Let's see. Oh, I have to remember to attach my script. So don't forget that if you make a new script, you're gonna have to attach it. So I'm gonna attach it to my player. And so now when I look at this, I can see that if you can't see it, it says you rolled a 1. So it's giving me back whatever this is. So like that's returning to here. So if it was a void function, nothing would happen with this. It would just execute the code inside of this function. But since it's a return function, it's returning back a value. So this gets replaced with that value. Does that make sense? Because if you've never seen it before, it might be confusing. So let me know if it makes sense in the chat. Makes sense? Not make sense? Other folks besides Randy Garcia? I gotta look up the names on my list. Questions. I know you have questions. Come on. What are your questions? So another thing we can do is we can actually make this work. Right now it's rigged, right? So it always gives you 1, a value of 1. So does anyone know what we can, like let's say we want to find out how to get a random value. Where's a good place to find out where to get a random value? Where would you go to discover that? Where are all the answers to all of your code questions? The Unity reference page and the internet, yes. So like all you have to do is just Google, you don't even have to spell it correctly. Just Google untiy random, and then the answer will come up. And so if I go here, it will actually show me this thing. So it will show me that there's a thing called random.range. And so it will actually return a value between a minimum value and a maximum value. So I can see that it takes a float for a minimum and a float for a maximum. And so there's also a way to do it with an integer. And in fact, like when you roll a die or dice, do you get a float or do you get an integer? Usually, let's say a with normal dice, nothing fancy, like 100,000 sided dice with 100,000 sided dice. You get a decimal number? Do you get like 1.5 or like 3.7? It's not a rhetorical question. Is that what you get? Maybe you have different dice, right? So you get an integer probably, right? You get like, for like a regular die, you get 1 to 6. Like the lowest value is 1, the highest value is 6. And so we can try to, so instead of doing a float, why don't we do an int, right? So an integer, so this will return an integer. And so I'm gonna get rid of this because we're gonna make a die roll that actually works. So I can, inside of this function, I can write, like, let's say die value. So that's like however much you're rolling. And so I can use random.range. So I can go back and look at this description of how it works. I can even see an example. So I know that the class that we're referring to is called random. And then range is a method of that class. It takes a minimum value and a maximum value. So it also says that it is inclusive of the minimum, which means that that is a possible thing you'll get from it, and it's exclusive of the maximum. So what that means is that you will not get that maximum, but you will get that minimum potentially. So we have to think about, like, what would the minimum and the maximum be here? So if we're talking about a regular 6-sided die, what would be the minimum inclusive be? We're talking the smallest value you can get. So Manny says 1 and 7. So 1 for the minimum. So like since it's inclusive, that means you can get 1. So I would write 1. And then for the max, he says exclusive of 7, meaning that you can get up to the one before that. So you won't get 7, you'll get between 0 and 6 if you put, or sorry, 1 and, I can't speak. You get between 1 and 6 if you do this. And so then we can return die value. So when this runs, it'll say you rolled a, it'll run die value. So it'll declare a new integer here called die value, and then it'll be assigned using this random.range function, and it'll give you a value starting at 1 and ending at whatever's below 7, in this case 6. And so it will, and this, the reason why it's exclusive here has a lot to do with how this works, because notice how it's inclusive here when you have the float. So this is the float version of this function, so you can use it with floats if you want to, or you can use it with integers if you want to. We want to use the integer one because dice are whole numbers. Has anyone worked with dice that have fractions? There might be ones with fractions. I don't know about decimal points. I feel like that's unlikely. But I'm not like a D&D person, so I'm not like, or like a Yahtzee person. I don't know dice that well. I feel like there might be fraction ones. Okay, but like when you talk about this float, it's inclusive because you can get a value between, let's say we did between 1 and 7. that means that you could get like 1, you could get 1.1, you could get 1.2, you could get 1.3, but you could get up to 7.0. You couldn't get 7.5 or 7.6. So like the likelihood that you would actually roll a perfect 7 would be so unlikely that it would just almost never happen. So if you ever find a fraction or a decimal die, send it in the chat on River. I want to see it. Okay. So does this make sense for how this worked? How we declared a new integer called die value, and then we used random.range, which will give us, if we put integers in here, it will give us it back an integer. If I give it a float, it will give me back a float. So since they're whole numbers, it's a minimum value of 1 going up to 7 minus 1 because it excludes 7. And then whatever that value is, it returns it. So I'm going to save this. I'm going to go back, and I apparently had the game running. I'm going to try running it again. And so this time it says I rolled it. I'm like, I forgot the command for like, no, that's, oh yeah, okay, cool. I was trying to remember the zoom thing. So you can see that you rolled a 2. I'm like, this thing makes me nauseous when I do it too much. How do I, it's like, I don't even know how to exit out of this. How do I feel like dummy. Okay, so I'm gonna try it again. So when I hit play again, this time I rolled a 1. This time I rolled a 1 again. This time I rolled a 4. So each time it's rolling a different value and it's giving me that inside of the console. So what I can do is, let's say that I wanted to make this responsive to the player. So instead of just making it for start, let's say that I wanted to check if a player pressed a certain key. So like I could create an if statement, and then I could use input. So that's the input class. And then I could use, does anyone remember what we can do to check if a certain key is being pressed in that one moment? What command that is? It's part of the input class. So it's a method of the input class to be able to check if a key is being pressed in that one frame. So if it's being pressed down. So does anyone remember what that is? What it's called? We used it in our other script. The other one we didn't. Get key down, you got it. So get key down, and so this will take, there are different ways you can write this. We can use key code, so key code dot, let's say, what's a good key for rolling a die? What key should we use? I'm just gonna wait until someone suggests a key. R? Okay. So that's a good one because we're not using it so far. So we can use, I think it's a lowercase r. And so here, we can actually, I'm just gonna move this line. So R is a good key because roll.
We're having some kind of powerful, weird alchemy, and you have to pay attention.
Wow, this song just tripped me up.
Not to be treated lightly.
Okay, so I'm gonna save this. I was like, who the hell's talking? So is it capital R, keycode.r?
But there may not be another time.
It gave me an error saying that it can't find lowercase r because it's a capital R.
Be able to return to this moment.
And so I'm gonna hit play, and I'm gonna press R, and boom, R, 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 and it's telling me how many times I've rolled each one. I can clear this if I want to. So does everyone see how this is working? How I'm like using the R key to like repeat this thing over and over. So I can run this this int function. And so you can see how like you could have, and you could do this with any kind of, like anything that you have that's like a data type where you have like an int or a float or like a Boolean or any of that stuff. You can make a function that of that type and you can have it return that value. So this returns a value, whatever die value is. So do people think this could be useful for them? So hopefully you can, at least with like, you know, rolling dice or something. So let's say that we want to, let's say we want to make a more advanced one. So let's say we want to create a dice roll. Let's say I'm going to create another one. So this one's going to be called dice roll. So if you don't know, a die is a single one and dice are plural. So if we're rolling dice, we don't necessarily know how many dice. So we might need to specify. So like what we can do is inside of the parentheses here, we can actually call, we can pass in a value. So let's say that we wanted to, when we call this function, let's say we wanted to specify how many dice to roll. So I could say int how many dice. So what this will do is when you call this function, when you call dice roll, so I'm gonna call, instead of, I'm gonna comment this line out and I'm gonna paste it down here. And so instead of doing die roll, I'm gonna do dice roll. And then inside the parentheses here, I have to give it a number. So like, let's say that I had 2 dice. So if I want to run this, it will actually pass this integer that I put in here. It'll teleport it down to here. So when it runs this, it will declare a new integer called how many dice, and it will be assigned this value. So like, for instance, I could say print line, how many dice. This might give me an error, but I'm just trying to see if, sorry, print line is print ln is not in C#. It's because I what's it called? I just taught processing right before this class, which is Java. So it's telling me I need a return value. So like, I'm just gonna cheat and just say how many dice. So what that's gonna do is, instead of giving me a dice roll, it's just gonna give me 2, right? So what it's doing is it's passing this value into here, creating a new variable called how many dice. And so we can use that in here. So I actually like don't want it to work like this because that's kind of dumb. But it's important for me to know how many dice because like in this case, we just did 1, right? So if I wanted to make this however many times, I would have to like, let's say, let's create a new integer called dice value. I'm just gonna make it 0 to begin with because it's gonna not be anything. And then let's say that we want to make a loop. I'm giving away the answer, damn it. We want to make something that happens many times, however many times. So like, let's say we have 5 dice, we want something to run 5 times. So what might we use for something like that? So we might use a loop, right? So like, what's a common type of loop we might use? So we might use like a for loop. So if you've taken 105, you're probably familiar with for loops and while loops. So when we create a for loop, and this is like the usual way we do it, right? So we create a new int called I, we give it an initial value 0, then we give it a rule. So like this will run however many times until as long as I is like let's say less than how many dice, because we want it to run once for each die. And then I++, which will increment the value each time. So this will run once with I being 0, and then it will add 1, roll it again until we hit the number of dice that we need. So now we need, so each time this runs, we need to add, so we can do plus equals, which will add whatever the value is on the right. So we can do random.range because we know that, so like if we roll this twice, this will run twice, right? So it'll add the value of the first die, and then it will add the value, it'll run again, and it'll add the value of the second die. And then we want to return dice value. So I feel like I just did a lot very quickly. Does that make sense at all? I'm assuming it doesn't. Does it make sense? So this time when I press R, notice how like the first time I got 4, the second time I got 6, the third time I got 9. So what that means is that it's adding up the first die and the second die. So if the minimum is 1, what's the lowest number I can roll with 2 dice? What's the smallest number for 2 dice? 2, right? So if you get 1 and 1, you get 2. And what's the highest value for 2 standard dice? 12, you got it. So in this case, so like we started off at 0, right? Because no dice have been rolled. And then in our loop, we're gonna run this loop. It's gonna run however many dice we have, that's how many times it's gonna run. So if we made it, let's say we made it, instead of 2, let's say that we made it like 500 dice. So now it's gonna, each time it runs, it's gonna add the value of each die it rolls 500 times. Now I'm just imagining like the kind of like Twitter like clapping emoji in between every word, but like 500 times, and each one is a dice emoji in between. That's a fun mental image. So now when I run this, now my dice can be very, very high, right? Because I have 500 dice. Just imagine if you had to like roll 500 dice and then you had to count each one and add them. That's the beauty of computers. It will do it for us, which is wonderful. A wonderful thing that computers do for us. So if I wanted to make this like more, I don't know, let's say I wanted to, instead of doing R, nah, R is fine. So I can make a public int how many, let's say, I guess it defeats the purpose if I just make it up there. So I was trying to think about like how to make it responsive to the player, but in terms of this example, it doesn't, maybe it doesn't make sense. So we could also make this like something that increased the number of dice that rolled each time. So if we were using a variable, we could add, you know, add a die, add the value, increase the value by an amount each time. So were people able to follow that? Were you able to get how we did the dice roll? We passed in the value. So this 3 gets teleported down here into a new variable. So it creates a new variable here called how many dice. It gives it an initial value of 3. And then we create a new variable called dice value, which will store the current number as far as like so if it runs the first die, it will add that to it. The second die will be added to it, etc. So it starts at 0 because we haven't rolled any dice yet. And then we have this loop, which will run so long it'll run once for each die that we have. And so dice value the first time will be 0, and then it'll be added to the results of the first die roll. And so like, let's say it's 5, so it'll be 5, and then it'll run again, the loop will run again. So then it'll be 5 plus the results of the second die roll. So like, let's say it's 6, so then it'll be 11, so on and so forth until it runs once for each die. And then when it's done, you'll have the final value for the total of the dice. And so it returns that value, the dice value, back here. So it basically like erases this code and replaces it with dice value. So when you look in the console, you rolled A and then the value of the final amount. Does that make sense? I feel like I just talked a lot. I feel like I'm talking more in my classes than normal. Cool, so I hope that's helpful. So hopefully it sounds like people didn't know how to use these non-void functions. So you learned something new today, not just like reviewing what you did before. So I hope that was helpful. Fun little trick. I think it's like one of the things with code is that oftentimes people will say something, but they won't explain why it's that way. And that's, I think, where it gets confusing. So like, you know, if you don't know what void means, for instance, then you don't know why you do it. You just know that it's void. But once you know like why it does it, so it means that this does not return any value, then it starts to make more sense in the overall picture. Okay. So anyways, so those are some custom functions. So like if we go back to our script, I said that the other thing that we were going to do today was we were going to, what did I say the other thing? We said that we were going to like, help me out. What are we going to do today? What's the other thing? I actually know, but I'm just curious, do you remember? Were you paying attention? So let me know in the chat. Something about trail. So you got it. So we're talking about like how when we move around in this space, we don't necessarily know where the player has been before. So, and it's okay not to remember. But do you remember now? Like now we're talking about like creating a trail. So each position that the player was in, we're gonna change the material. Does that sound familiar, Felix? If not, it's okay. I have bad memory. If you can't tell. Okay, so now we're gonna think about like, so the 3 in the comment set the number of dice, right? So this part right here, so like we passed that value, right? So that's what determined how many dice, yeah. Okay, so what we can do is we can, if we want to change the material, we can store another material in here. So like I could go into my project view and I could, do you want to change the material or do you want to change the color? What's more interesting to you? Because we can do either one. We can change the color might be more interesting. What do you think? New material for the trail or a new color? Okay, so we got material. So someone said material clips. Ooh, I've already forgotten because I don't have my handy code thing up. Randy Garcia. Cool, so Randy wanted to do a material, so we're gonna do a material. So at the top, I'm going to declare a public material. So again, material, like all these things is just a class somewhere. Oops. This mouse is like not great. So I declared a public material. So like it's just a class somewhere in Unity. So that's all it is. So I'm writing a, I'll call it trail mat. Trail mat stands for trail material. And then if like we have to think about like when this is happening. So we're like, and so if I think I saved it. Control S. If I go back to Unity, I go to my script. So now I see that there's a new material here. So I'm going to go ahead and create that new material in my project view. So let's say that I want to create a new material. So I right click, create material. I'm going to call this one trail. And then what should that material look like? Should it be like, should it have like flat shading? Should it have shadows, no shadows, smooth, metallic, transparent? What do you think? I can't make my own decisions. I expect you to make them for me. So tell me what to do. What should it look like? So we got transparent and smooth. Okay, so I'm gonna pick the color myself. Yeah, I agree. Yeah. So when you say smooth, do you mean like this or like this? Do you want it to have this kind of like shine look to it, or do you want it to be matte? Because I feel like it's a little bit counterintuitive. So if we also want to have it with no shadow, if you remember, the emission will actually create a fill color. So like if we want to give this, like, let's say we want to have, we could give it maybe like this. And it basically like fills in the shadows there. And so if we want to make it transparent, we have to go here and we can use fade. And then when we go back into the color, we can change the alpha here, which will determine how transparent it is. And you can always use the preview, like, which I'm probably like covering up. So now we have our trail material. So I want to go back to my player and I'm going to assign that. So let's say trail. And so now we're going to go back to our script because we haven't actually done anything with it yet. So what we want to do is we want to basically check if the player's position is the same as anything in our field. So remember, field is the parent game object of all the tiles, everything in this space, right? So all these things. And so we want to basically check if the player's position is the same as any one of these children. If it's the same as one of the children, that means it's in that spot, and we want to change the material to be the trail material. Does that make sense? So if I want to be able to do that, I'm going to have to first create a new public transform that I can assign. So this is going to be the field parent. So the parent of all of the game objects in the field. So if I go back to Unity, and then I'm going to go to my player, so I can go back to my script. And field parent, I can just drag field into there. So that will be like that. So we can actually, this mouse is awful. I swear I didn't do that. Okay. It's a very expensive mouse too. It's like $45. You expect more from these things. Probably playing too much cookie clicker. Okay, so we have things like update position, we have things like controls, so we might create a new function here. Let's call it create trail. And then I'm gonna actually make it down here. So this is going to be a void function. I'll call it create trail. And then what we want to do is we want to check the position of each child to see if the position of our player is the same as the position of the first child, of the second child, of the third child, of the fourth child, all the way through all the children. So what does that sound like we should use if we're going to do it over and over and over and over and over again? So yeah, we can use a loop, right? So I'm going to create a for loop. I'm going to use it the same way we did for the other thing. So int I equals 0. And of course, we don't have to format our for loop this way. It's just easier. So we want to make sure that we are running this for a number of times. So what is going to determine the number of times that we run this? If we want to run it for each child, what would we use for the number of times to run it? How would we get that? Maybe not like in code, but just like, what is that number? Like not the number itself, but just like, what is it? I don't know if that makes sense. I hope it makes sense. So if we want to do it, and give me like an emoji if you're like, what the fuck is she talking about? Or I guess, does it have another name? It's like not an emoji, it's like a, is it an emoji? I don't even know if it counts. It's an emote, sorry, an emote. So the question was, so what we're doing is we're creating a, we created a void function for creating the trail, and we're creating this. So like, remember that we're trying to figure out how many times we should run this. So how many times should we run this loop? So it should be determined. We want to do it for each child. And so I'm just going to give you the answer. The answer is for however many children we have. So we need to know how many children the field has. So the field is the parent, right? Each of the ones underneath of it, each of the underlings is a child. And so there's something we can use called child count. So child, and does that help contextualize things a little bit better for folks that were unsure? So remember that we created a new public transform called field parent. So we assigned this to be field, right? And so what we can do is we want to make sure that it runs the number of times based on the number of children. So I can put the field parent, and if I use dot notation, it's called child count. So this is like the number of children, the number of ones inside of it, and then I++. So this will run, it'll start off at 0, and then it'll become 1, 2, 3, until it gets through every single child. It will run. And so what we want to do is we want to check the position. If the position is the player is the same as the position of the trail, then we want to modify that. So I'm going to write if player transform dot position. So this is like the similar to how we checked it before, right? So we checked if the player position was the same as like a hazard. So now we're checking if the player position is the same as our children. So each one of our children in field parent. So if you want to access a specific child of a parent game object, you need to use what's called get child. So, and it's a method of transform. So we know that field parent is a transform. So I write field parent dot get child, and then open and close parentheses. Inside of that, you give the index of the child. So like, which child are we talking about? And so what should we use here that will initially go for child 0, and then it'll go for child 1, child 2, etc. until we get through them. So like, what thing do we have already that we can use to put inside here to specify which child that will update each time the loop runs? What should we use? So what's automatically updating inside of this loop every time? Every time it runs, what variable is updating? So I, right? So I can actually put I inside of here. And so we know that, so this will give us the transform of the child of this index. So in the first time this runs, this will be the first child, child 0. And so this will give us the transform of it. So if we want to access the position, I write dot position. So it's saying if the player transform dot position is the same as field parent's child, this child, which in the first time it's going to be child 0 position. So the position of this versus the first child's position, if it's the same, then should we change the material to the trail, or should we leave it and not change it? What do you think? Leave it or change it if the position of the player is the same as the child? So change it, right? Because that's the idea. We're trying to change the... What are we trying to change? We're trying to change the trail. We're trying to create a trail behind it. So we have to then change the... So we're going to have to do this is going to be a long line of code. So bear with me. All right, so we need to, again, access the child. So like one thing, actually, maybe I can make this easier. Nah, this is not going to help. Okay, so we know that we can refer to this current child by field parent dot get child and then I in parentheses. So I can write field parent dot get child I. And then if I want to access the material, so like if we look at, let's say this is the tile that is going to be changed. And so if we look at it, the material itself is stored in the mesh renderer. So if you look here, I can see that, so like it's part of this game object, right? So transform is a part of the game object. So we need to access the game object itself. And then we need to access the mesh renderer component, because that's where we can modify the material. So we need to first, so right now we have access to the transform. This will give us the transform. So we need to, if we need to access a game object from a transform, and you can look this up if you're not sure. Let me see. So if you go to the documentation page, so you can see all the stuff I talked about. So like you can see child count, you can see get child, stuff like that. And you can also see that you can access game object from it. So the components are attached to the game object. So the transform is usually, you can see that the transform is attached to this game object, but so we need to access the game object from the transform. Does that make sense? Because I feel like it's a little bit confusing because transform is a part of a game object, but we can't jump to another component. We have to go first to the game object, and then we can access another component. Does that make sense? So we can't go deeper into this, and like let's say we're inside of the transform. We need to escape to the overall game object itself, this whole thing, before we can reach into this bucket. So we can't access this bucket from here. We have to first exit this bucket into the bigger bucket, which is the game object bucket, to access the mesh renderer bucket. Hope it makes sense. Because it's like a lot of words, you know? So we have to access the game object. Keep in mind that it's an object. It's not a class, so it's a lowercase g. Usually like method names start with a capital letter, and objects or properties start with a lowercase letter. So that's how you can tell them apart. So like for instance, if we were declaring a new game object, we would use capital G because we're saying like we want it to be of this class, not an object. So if we want to access a component, have we done that yet? Have we done anything with modifying components? So we did here, right? So we accessed a component. We accessed the audio source. Remember that? So we can use this the same way in order to access our renderer. So we can use get component, and then we use less than greater than open close parentheses. Inside the less than greater than is the name of the component. Mesh renderer is, we could just put renderer. And so then we can access this component here. And so if we want to access the material, we can then access dot material, and we can set it to be something else. So we can set it to be trail matte. So that's like a long line of code, so it's a lot to it, right? So I'm just gonna try to run it, see if we have any errors, and then I'll go over it again. No errors, thank God. Is it working? So I think it's working, right? So now you can see that like every piece we're traveling to is actually changing colors, which is nice. So then like we can visualize exactly where we've been. So, yeah, so like normally I would be having everyone like try it on their own. Maybe we'll do that. So everyone said that they're okay switching back and forth between things. So we're gonna, for this lesson is gonna be over, but for those of you that are in the class, we're gonna resume back on Blackboard Collaborate Ultra for like a last little bit, so that you can practice this yourself and see if you can do a little bit more with it, okay? So I'm gonna go ahead and every time I'm gonna make sure that I'm gonna save this as week 4 for the scenes. And then at the end of class, I'm gonna go through and I'm gonna make sure that my Git repository, I'm gonna commit everything, I'm gonna push it to the server, so everyone will have access to it. So for those of you that are in the class, I will see you back on Blackboard Collaborate Ultra. Just right now, just like head back and I'll see you there. And I'll see you there in a minute or two. Okay? Goodbye. I gotta close this out now. Goodbye.